Hey there, future bioinformaticians. Ready to unlock the secrets of life using the power of AI? Buckle up, because we're diving into the exciting world where biology meets artificial intelligence. Imagine predicting diseases before they even appear, or discovering life-saving drugs with just a few lines of code. That's the magic we can create with bioinformatics and AI. In this step-by-step guide, we'll demystify the process of building your very own AI tool for bioinformatics. Whether you're a coding enthusiast or a biology buff, get ready for a thrilling adventure. Are you excited? Let's get started. Before we embark on our AI journey, let's get a grip on the basics. Bioinformatics is like being a detective, but instead of chasing criminals, we're solving biological mysteries hidden within massive amounts of data. DNA sequences, protein structures, you name it. Now imagine having a super-powered sidekick. That's AI. AI helps us analyze these massive data sets, spot patterns humans might miss, and make predictions. It's like having a super-powered microscope for biology. Think of it like this. Bioinformatics provides the raw ingredients, and AI is the master chef that transforms them into a delicious dish of discovery. Ready to get your hands dirty with some code? Our weapon of choice, Python. It's like the Swiss Army knife of programming languages, perfect for bioinformatics. First things first, download and install Python. Don't worry, it's as easy as installing your favorite game. Next up, we'll need some special tools, libraries like BioPython and scikit-learn. Think of them as power-ups for our Python code, giving it specific abilities to analyze biological data and build AI models. Once you have these libraries installed, you're all set. It's time to dive into the data. Data is the lifeblood of bioinformatics. It's the foundation upon which we build our understanding of biological processes and develop new technologies. Without data, we would be navigating in the dark, unable to make informed decisions or discoveries. It's like the raw clay we use to mold our AI masterpiece. Just as a potter carefully shapes and refines their clay, we must meticulously prepare our data to ensure it is ready for analysis. This process is both an art and a science, requiring attention to detail and a deep understanding of the data's context. But before we get creative, we need to make sure our data is squeaky clean. Data cleaning is a crucial step that involves identifying and correcting errors, filling in missing values, and ensuring consistency across the dataset. This step can be time-consuming, but it's essential for producing reliable results. First, let's load our dataset. This could be a simple CSV file, a complex database, or even real-time data streams. The source of the data can vary widely, but the goal is always the same, to gather all relevant information in one place for analysis. This could be anything: DNA sequences, protein structures, or even patient medical records. Each type of data comes with its own set of challenges and requirements for cleaning and preparation. For example, patient medical records need to be anonymized to protect privacy, while DNA sequences must be checked for sequencing errors. Understanding the specific needs of your dataset is key to effective data cleaning. Once loaded, we need to roll up our sleeves and do some cleaning. This involves a variety of tasks, such as removing outliers that could skew our results, standardizing data formats, and ensuring that all data points are accurate and relevant. Think of it as removing unwanted weeds from a garden. Just as a gardener carefully removes weeds to allow their plants to thrive, we must remove any erroneous or irrelevant data to ensure our analysis is accurate and meaningful. We'll deal with missing values, remove duplicates, and address any inconsistencies. This might involve using statistical methods to estimate missing values or developing algorithms to identify and correct errors, and make sure everything is in tip-top shape. A well-cleaned dataset is like a well-tuned instrument, ready to produce beautiful music. It ensures that our analyses are based on accurate and reliable data, leading to more trustworthy results. Remember, garbage in, garbage out. If we start with poor quality data, our results will be equally poor. That's why data cleaning is such a critical step in the bioinformatics workflow. Clean data is crucial for building a robust and accurate AI tool. By investing time and effort into data cleaning, we set the stage for successful analyses and meaningful discoveries. So, let's get started and make sure our data is in the best possible shape for the exciting work ahead. Section 5. Preprocessing power, preparing data for AI. Raw data is like a wild horse, powerful but untamed. It holds immense potential, but in its raw form, it is chaotic and unstructured. This raw data can come from various sources, such as genomic sequences, protein structures, or even patient health records. Each type of data has its own unique challenges and requires specific preprocessing techniques to make it usable for AI applications. Before we unleash our AI algorithms, we need to tame it through preprocessing. This involves cleaning the data, removing any noise or errors, and transforming it into a structured format. Data preprocessing is a critical step because the quality of the data directly impacts the performance of the AI model. Think of it as grooming the wild horse, making it ready for the race. One crucial step is feature engineering, where we transform raw data into a format that our AI can understand. This involves selecting the most relevant features or characteristics of the data that will help the AI make accurate predictions. Feature engineering can be a complex process requiring domain expertise and a deep understanding of the data. For example, we might convert DNA sequences into numerical vectors. This allows the AI to process the genetic information in a way that it can understand. By converting the sequences into numbers, we can apply mathematical and statistical techniques to analyze the data, or extract specific features from protein structures. This might involve identifying key patterns or motifs within the protein that are relevant to the problem we are trying to solve. By focusing on these important features, we can improve the accuracy and efficiency of our AI model. Next, we'll split our data into training and testing sets. The training set is used to teach the AI model, while the testing set is used to evaluate its performance. This step is crucial because it helps us ensure that our model is not just memorizing the data, but actually learning to make accurate predictions. This is like giving our AI model a set of practice questions and a final exam to test its knowledge. The training set is the practice, where the model learns and improves. The testing set is the exam, where we assess how well the model has learned and how it performs on new, unseen data. With our data pre-processed and ready, it's time for the main event, building our AI model. This is where all the hard work of preprocessing pays off. A well-prepared dataset can significantly enhance the performance of the AI model, leading to more accurate and reliable results. So, let's dive into the exciting world of AI model building and see what we can achieve with our meticulously prepared data. Building a decision tree classifier. Let's build a decision tree classifier. Imagine a game of 20 questions, where each question helps us narrow down the possibilities and arrive at an answer. That's what a decision tree does. We'll use scikit-learn, our trusty AI toolkit, to create and train our decision tree. We'll feed it our training data, and it'll learn the patterns and relationships within the data. Think of it like teaching a dog new tricks. With enough training and positive reinforcement, our decision tree will become a master at making predictions. Putting your AI to the test, evaluation, and deployment. Our AI model is trained and ready to go, but before we release it into the wild, we need to make sure it's up to the task. This involves a rigorous process of evaluation to ensure that our model performs well under various conditions and scenarios. We need to be confident that it can handle real-world data and provide accurate, reliable results. This is where model evaluation comes in. Evaluation is a critical step in the AI development process. It helps us understand the strengths and weaknesses of our model and identify areas where it may need improvement. By thoroughly testing our model, we can ensure that it meets the necessary standards and performs as expected. We'll use various metrics to assess our model's performance, such as accuracy, which measures how often the model's predictions are correct. Accuracy is a fundamental metric, but it's not the only one we need to consider. Precision, which indicates the proportion of true positive results among all positive results, and recall, which measures the proportion of true positive results among all actual positives, are also crucial. These metrics help us understand how well our model is performing in different aspects. Think of it as grading our AI model's exam. Each metric provides a different perspective on the model's performance, and together, they give us a comprehensive view of its capabilities. By analyzing these metrics, we can make informed decisions about how to improve and optimize our model. Once we're satisfied with its performance, it's time to deploy our AI tool. Deployment is the process of making our model available for use in real-world applications. This step is crucial because it allows us to see how our model performs in a live environment and gather feedback for further improvements. This could involve creating a web application, a command line tool, or even integrating it into an existing bioinformatics pipeline. Each deployment method has its own set of challenges and considerations, but the goal is always the same: to make our AI tool accessible and useful to end users. Integrating our AI model into a bioinformatics pipeline can enhance the efficiency and accuracy of bioinformatics analyses. This integration allows researchers to leverage the power of AI to gain deeper insights and make more informed decisions in their work. Congratulations, you've just built your very own AI tool for bioinformatics. This is a significant achievement, and it's just the beginning. With continuous evaluation and improvement, your AI tool can become an invaluable asset in the field of bioinformatics. The journey begins, conclusion, and next steps. We've covered a lot of ground, from understanding the basics of bioinformatics and AI to building and deploying a decision tree classifier. But this is just the beginning of your AI adventure. The world of bioinformatics is vast and constantly evolving. There are endless possibilities for applying AI to solve biological problems and make groundbreaking discoveries. So go forth, experiment, and never stop exploring the incredible